We have started the second concept of light. The major discussion was yesterday about refraction. We have learned what is refraction. Anyone can give me the answer? Refraction definition. Yeah.
The change in direction of path of light when passes from beginning
Okay, fine. Okay, fine. So the change. Okay, fine. You're right. So when the change in path of direction or direction of light when moving from one medium to another medium, there is a deviation. That deviation is known as refraction. The terms related to refraction. The first term related to refraction. It's about medium. Yeah, we have two mediums. Yeah, that we have discussed yesterday. First one is denser medium, rarer medium. Okay, now I'm asking about the terms related to refraction. Incident ray. Yeah, great. Yeah, incident. Yeah, refracted ray. Normal. Angle of incidence. Angle of reflection. Angle of refraction. Great. Okay, these were the major discussion we have done yesterday. Now we are going to the next topic of this chapter, law of refraction. So next topic, law of refraction. Law of refraction. Okay, there are two statements in law of refraction. There are how many statements are there? Two statements. The first statement in law of refraction. Okay, I have a question to you. How many rays or lines we can see in refraction? If a ray of light is refracting, how many lines or rays we can see? Three rays are there, three lines are there. Maybe it's a glass slab. The first line, incident ray. Second one, a normal, great. Second line, normal. Third one, refracted ray. I think you are clear that. The first law is a relation between these three lines. First line, incident ray, normal and refracted ray. All three lines are, rays are lying in same plane. That's the first statement. Incident ray, refracted ray, and the normal lie in same plane, P-L-A-N-E, plane, not P-L-A-I-N, it's P-L-A-N-E. Can you repeat that with me? Come on. Incident ray, refract, same plane. Okay, fine. That's great. So I am giving, what do you mean by the same plane? Okay, you just see, if I am taking something, a book or tube, okay, see this duster. you can see. How should be, you can see, I think this is the incident ray. Okay. It may be the normal, it may be the refracted ray. Are you with me? Are you with me?
Yes.
Yeah. So, when we discuss about plane, see the surface of this duster is this portion, this is the plane. Above, this is one plane, and down also same plane, because when I am moving my hand, now it's in a same plane. This is the one plane. Okay, if this is the one plane, we can see incident ray, normal, refracted ray, all are in same plane. Are you with me? You got it?
Yes.
Otherwise, what is second plane of this one? Second plane is like this, front and up. This is another plane. This is the one plane. We say x-axis. This is the, no sorry, this is the x-axis. This is the y-axis. So y-axis is a plane, x-axis is another plane. So the first statement is this: incident ray, refracted ray, and the normal lies in same plane. Very good. Second statement of law of refraction. You just learn this statement, because the technical terms you have to learn in the next year in mathematics. Then only you can understand words. But you have to learn now as it is. The ratio of sin I and sin R, the ratio of sin I and sin R is a constant. So we can write sin I by sin R is equal to a constant. This is the second statement. So we have two statements. First one, incident ray, refracted ray, and the normal lie in the same plane. Second statement, the ratio of sin I and sin R is a constant. That means sin I by sin R is equal to a constant. What do you mean by sin? Sin is related to angles. It's a relation between angles. So next year when you start trigonometry, you learn sin I and sin R. So for time being, just learn it by heart. The ratio of sin I and sin R is a constant. So this is known as law of refraction. So there are two statements in law of refraction. First statement, the incident ray, the refracted ray, and normal lie in same plane. Second statement, the ratio of sin I and sin R is a constant. Okay, sin I by sin is equal to constant. This is known as law of refraction. Law of refraction has another term or title or name. It is Snell's law. S-N-E-L-L'(S). Snell's law. It's another term for law of refraction. So if you ask, write Snell's law, what is that? Law of refraction. So law of refraction is also known as Snell's law. This is the third concept. So first we talk about medium, second refraction, third one law of refraction. I think you are clear. Are you clear, dear? Yes, dear. Thank you. So, we are moving to next topic, effects of refraction. Effects of refraction. Just try to understand, very simple. So, fourth one, effects of refraction. Effects of refraction. Okay, I will give you an example, then I will just tell how it is happening or not. Take a glass, put a coin here, any coin here. You are looking from the upside, your eyes is here. My goodness, it becomes shite. So, you are looking from here. So, you can see the coin here in the down part. But you think, I am giving another instance or situation, we are pouring water. We poured water here. If you pour water, now we are looking here, the light ray is coming from, and what will happen? It is entering into another medium. So, what will happen? Refraction will happen. So, it is supposed to go like this, it is just turn. Okay. So, that is happening. It will turn like this. There is a slight, or if you see a straight line which is coming from a slight thing, your coin is here, a slight variation will happen. The same way, light will come from different sides and it will be reflected back, and they will meet at a point. So, where two lines of rays from a source meet, image will be formed there. Think what I am saying. See, one line came here, it is undergoing refraction. So, that is one line. Okay, that is the one line after refraction. Another line I told, from here also reflector ray will come, it will meet. When two rays of light comes from a source meet, there should be a image. So, image of this coin will form here. So, when we look a coin through water, we can see the coin just above the actual position. Are you with me? Are you with me?
Yes.
Yes. So, question is very simple. When we, question is very simple. When we look any object from above into water, the depth will be less or more. Actual depth will be effect in the sight.
The depth will be less.
Depth will be less. Are you with me? Okay, so question is very simple. First effect, when we look or observe an object in the water
Yes.
from above the depth will be, the depth of object will be less. Okay. Why? Why? Because of refraction. That's your answer. You have only very simple question. When we look an object in the water from above, the depth will, or the depth object will be less or more. That's the question. Why? Depth will be less. Why? Because of refraction. So that's only you have to learn. You no need to learn about this theory and all. Okay, how it happens, you no need to worry. You have to worry about only these two answers. The phenomenon behind the observation of an object in less depth. What is the phenomenon? Refraction. Or question will ask in another way, when we observe an object in a water from above, the depth will be less. Why? Because of refraction. Whatever you put, you just put your pencil in water. The tip is here, pen or pencil. Actually, what will happen? The tip will see here instead of seeing here. It will appear just above. Depth will be less. The actual depth will be more, but the observing depth will be less. Because of refraction. Are you with me? Are you with me?
Yes.
Yes, okay. Okay. Yeah, okay, very good. Second observation. Second effect. So first effect, depth will be less. Second effect. Yeah, see, is our earth. Around earth we have atmosphere. Very good. Atmosphere. Atmosphere. Atmosphere is made up of air or mixture of gases, dust particles, minute particles. That is atmosphere. So there is a covering around earth, that is atmosphere. See, one person is standing here in this one. Okay, so he is standing here. So sun is rising. Sun is rising from here. Sun is coming up, slowly coming up. Actually, sun reached here, you think. So we are thinking about sunrise. You know what is sunrise? Sun is rising up. Think. Here we have atmosphere. It's a larger circle. Person is standing in the atmosphere. Yeah. Sunlight is coming through vacuum. Okay. Here no air. No air. Now it is coming into. Now it is enter into. Yeah. It is denser or rarer? Atmosphere is denser or rarer compared to vacuum? My question, listen to my question. Now it is in vacuum. It is entering into atmosphere. So it is moving from which medium to which medium? Here rarer medium. Rarer to denser medium. So what will happen? What will happen? Refraction will happen. So see, if you see a normal here, it will move to which direction? it will move to which direction? Rarer to denser. Question. Just now it is entering from rarer medium to denser medium. Near to normal. Very good. So it will bend like this. Are you with me? Are you with me? So see, sun is here. Sun is coming up only, but he can see because of refraction. So we can see when in the morning we observe sun, but sun is not actually in our distance. It is just down. We can see sunrise little early. So second point, early sunrise. Early sunrise is due to refraction. Are you with me?
Yes.
That is second effect. Normally when we observe sunrise, sunrise will happen just before actual sunrise, because sun is coming only, but before that we can see sun because of this one, refraction. I think I am clear. Okay, third observation. Or third effect. So second effect about sunrise. Third rise about sunset. About sunrise, we have the experience of early sunrise due to refraction. About sunset, think, our earth, there is an atmosphere. You are standing here in the atmosphere. Think, sun is going down. Sun is reached here now. Sun is already set. Sun is already gone down. But problem, light ray will come here, entering to atmosphere. What will happen? Refraction. Even though sun has gone down, you can see sun again. Little more time. Why? Refraction. So third observation, late sunset. The reason for late sunset is refraction. So in the morning we can see sun little early. So there is early sunrise because of refraction, and there is late sunset because of refraction. Okay? Are you clear? Anybody? Are you clear? Yes, okay, fine. Okay, fine. That's the third, three effects. Okay, fine, good. So first effect is when we observe an object in the water, depth will be less. Second one, there is a phenomenon of early sunrise. And third observation, there is a phenomenon of late sunset. Fourth one, mirage. M-I-R-A-G-E, mirage. It is pronounced as mirage, not mirage, mirage. I think you have already learned your phonetics. E sound, then R sound, then R sound, then sh. Mirage, that is the sound, not mirage. Mirage, M-I-R-A-G-E, mirage. What is mirage? When we go through desert, if you see a palm tree, illusion, say illusion. We can see that feel of water when we look into a very hot road, when you are walking through road or traveling through road in noon time. If it's very hot, we can see there is a feel of water in the road. If there is no water but there is an illusion, we can see that there is a presence of water. That is known as mirage. as type of illusion. It is not actually there, but we feel that on top there is water. Okay, see, when you go to desert, if you are traveling on a camel, if you just look down, you can see a inverted image of palm tree. We can see an inverted image of palm tree if there is water, but in desert there is no water. Still we can see an image, inverted one. That is known as mirage. Are you with me? Have you got what is mirage? There is a feel of, there is an appearance of image even though there is no water. That is known as mirage. How it happens? Because when we see desert, our desert is here, full of sand, we have air above it. Air is always in a layer way. So, first layer air, second layer air, third layer air. Air is always like that. Different layer will be there in air. Even water also same way. It has different layer. How can we understand when you put some, you just drop a leaf or flower petal in water, we can see in the flowing water, sometimes it may not flow. But when we go down, the current is so fast. Maybe in the top we cannot feel that water is moving very fast, but then down it is very fast. Sometimes down it may be very calm, but at the top it will go very fast. So, layers will be different speed. Just like air also same layers we have. So, the layer just above the sand is too hot. Because of it is very close to sand, sand is very hot. So, it will be expand. The first layer will be expand, very rare medium. Density is very less. But just to move up, again temperature is there, but comparatively the first layer it is less. So, it is little more denser. So, when moving up, density will be changed. Are you with me? You got the point? Yeah, simple. I will repeat one more time. There are layers in atmosphere. The layer which is close to sand or surface will be too hot. When something is too hot, it will expand. When expand, what will happen? Density will be less. So, first layer density less. Density less is known as rarer medium. So, density will be increase. So, going up layer to layer, then it will become more denser medium. So, this is another is a denser medium, this is another medium, this is another medium, this is another medium. So, each layer can consider as a different density. Maybe it is made up of air only, but density is different. So, what is the possibility when light passes from one layer to another layer? What is the possibility? When means which possibility? Refraction. That's a technical term. So, layer to layer there is refraction will happen. So, our light may be come here, again bent, again bent, again bent, and it will go like this. So, we can see the top of the, we are looking like this, but bending will happen, and see the top edge in the down. Are you with me? Are you with me? Yes. Okay. That is scientifically happening. But we have to learn one thing, simple. When we travel in desert, we can see mirage. Why? When we travel in refraction, that's only we have to learn. We have to learn only one thing. If you don't know the explanation, don't worry about it. We have to learn only one thing. If you know the explanation very good. If you understood, it's very good. But concept is very simple. When we travel in desert, we have the experience of mirage. Why? Refraction. When we travel in road during noon time, when temperature is very high, we have seen mirage. Why? Because of refraction. Refraction is the reason behind mirage. Okay, these are the 4 effects of refraction. First one, when we look something in the water from above the surface of water, the depth will be less. Second one, early sunrise due to refraction. Third one, late sunset is due to refraction. Fourth one, mirage is due to refraction. What's the time now? Okay. Okay, I think 2:31, so we can move up little more. You fed up or not? Can we move up? Can we move up?
Yes.
Thank you.
Yes.
That yes is not that much sharp. Yeah, this yes is okay. So fourth point, effects of refraction. I think you are note down points with me. Okay? Okay. The fifth point, refraction in glass slab. Refraction in glass slab. Okay, we have told about what is glass slab, a piece of glass. Refraction in glass slab. Try to draw with me if you have book and pen with you. Refraction in glass slab. Can I move up? Can I move up? Yes or no?
Yes.
Okay. So we have a incident ray. Incident ray falls on the surface of glass slab. Okay. So this is the point of incidence. We can draw a normal here. So it is from a rarer medium to denser medium. So to what direction it will bend? Close to the normal. Yeah, it will bend close to the normal. Very good. This ray is known as incident ray. This is known as refracted ray. Okay. Are you with me?
Yes.
Nothing too much. I just bent a little more. That's why I just drawn again. Okay. Okay. So it is now moving through which medium? Glass. Again, it is moving from denser to rarer medium, again to air. So this is also a point of incidence. We can draw a normal. So the ray will be come closer or away? Away, because it is from glass to air, denser to rarer. So it will move away. Are you with me?
Yes.
This is the refraction in glass slab. You have to draw this picture. If somebody asks, refraction glass slab, incident ray, it will come close, again it will be deviate away. Okay?
Yes.
Yeah. Now we are moving to next concept. Yeah, come on.
That third ray in name is the
What's the name of third ray? What's happened to it?
refraction.
Refracted ray. So this ray is also known as
Refracted ray.
This is a refracted ray. This is a refracted ray. It has also incident. No? Okay. So it is also known as up to this point it is incident ray. Here incident ray falls on here. It got refraction. Now it became refracted ray. When it reaches this another edge, it become incident ray. Again it got refracted. Okay, very good question. Now moving to refraction in prisms. Refraction in prisms. Refraction in prisms. What do you mean prism? Prism is a glass slab in the shape of triangle. Very good. Triangle. Okay. Just follow me. This is the point of, this is the ray of incidence. Incident ray. Just draw with me. Very simple. Incident ray. So this is the point of incidence. There we can draw normal. Normal should be 90 degree with the surface of incidence. This is the surface of incidence. So we drew a normal. It will bend towards or away. Come close. Am I right?
Yes.
Because I have two glass. So it is bent down. Actually it is supposed to go to this way, but it is come close to normal because rarer to denser. So it became which ray? Name of this ray? Refracted ray. Very good. Refracted ray. Here again there is a point of incidence. So it become a incident ray. Here we can draw a what I am drawing? Normal. Very good. So which medium to which medium? Denser to rarer medium. So it will come close or away? Away. Yeah. This is the refraction in prisms. Are you clear?
Yes.
Very good. So we have learned fifth point, refraction in glass slab. You have to know how to draw. Sixth one, refraction in prisms. Okay. Okay. Yeah. Now I am going to wind up the session with the last topic of this day. Dispersion. Sixth one, dispersion. D-I-S-P-E-R-I-S-I-O-N. Dispersion. Yeah, so dispersion. Okay. Can I move up?
Yes.
Okay, fine. See, when you take a sunlight, so what we are taking? Sunlight. How many colors are there? Vibgeo. 7 colors are there. So, a light ray from the sun consists of 7 colors. Are you clear with that?
Yes.
Okay. When it falls on a prism, what will happen? It will have refraction. It will have refraction. Are you with me?
Yes.
Okay. But there is a possibility if the density of this medium is too high. Are you with me?
Yes.
If the density of this medium is too high, how many colors are there? 7 colors. V, I, B, G, Y, M-O-R. Violet, indigo, blue, green, yellow, orange, red. Yeah. Every color has different wavelength. Have you got the term wavelength?
Yes.
Yeah. Violet may be small wavelength. Indigo has little more wavelength. Blue has little more wavelength. Green has little more wavelength. Yellow more than that. Orange little more. Red too much. That's why we are using red in where? In signals. Why? It has more wavelength. It can see from far. Are you with me? Yeah. That's why we are using. So, our colors has different wavelength. Okay, come back. A light ray falls on a prism. There are different wavelength. If the prism's density is more, sometimes every colors cannot pass very smoothly because of wavelength. Because of the difference in wavelength, every colors cannot move at the same speed. Who will pass very easily?
Violet.
Who will pass very easily?
Violet.
No, violet is less wavelength. Red will pass very easily. So red will pass very easily. Then who will pass? Orange. Then who will pass? Yellow. Then who will pass? Yeah, so there is a possibility of splitting of light. Are you with me?
Yes.
Because of the difference wavelength. That phenomenon is known as dispersion. When a light moves from one medium to another medium, there is a possibility of splitting into components, colors. Are you with me? I will repeat. When light moves from one medium to another medium, there is a possibility of splitting into components color. Are you clear the word components color?
Yes.
Because white light consists of 7 components. This phenomenon is known as dispersion. So how can we define dispersion? Anyone can try. Please. Where? Great. Dispersion. When light moves from one medium to another medium, there is possibility of splitting into component colors is known as dispersion. So with dispersion, I am winding up. So 7th point is dispersion. Are you with me? So next class we will move to spherical mirrors. With that we will wind up this chapter. Thank you. Is it clear for you? Pardon?
That's why we are seeing rotating colors of 7 colors while it is up as well.
Which one? Yeah. And where is a clear observation, dispersion we can see in the life? There is a very clear observation we can see in the dispersion. Where is the evident example of dispersion?
Prism.
Not prism. In our daily life.
Colors.
Color disk, okay. Color is a combination color. Dispersion, splitting of light, where we can see. Rainbow, great. Where is dispersion happening? Very high. How it is happening? When? At what time rainbow will come? At what time rainbow will come?
After rain.
After rain or before rain? So what is there in the atmosphere? Sunlight's okay. What is there? Actually, what is there in the sunlight in the sky that time? After, before rain? The possibility, what is there? What is rain? Rain consists of what? Water. Water molecules are there. So when light moves through water droplets, there is a possibility for? No. When sunlight passes through, splitting into colors. Single term, dispersion will happen. So when light rays comes through waters, if water density is more, means rainy time, there is a possibility of dispersion. That's the reason for rainbow. So you have to understand the reason behind rainbow is conclude. The reason behind rainbow is, in single term, the reason of rainbow is dispersion. Thank you. May God bless you. We'll meet again.